Soldering and brazing tips and techniques for Super Alloy 5. The Super Alloy 5 rod is 18 inches long and comes in 1/16 and 3/32. The 1/16 is excellent for repairing thin aluminum such as home, auto, and commercial air conditioning units, auto radiators, and evaporators. The 3/32 works well for bridging gaps, larger holes, cast aluminum, a variety of more significant thicker aluminum. If you already have the 3/32 rod, you can take a hammer and flatten the rod to your desired thickness. This torch tip will not work with the Super Alloy 5. Propane can provide more heat than this tip will allow. This Bernzomatic torch is employed for the majority of aluminum videos on our site when using MAPP gas and propane. From my experience, the torches that have an adjustable flame control tend to work a little better and can push more heat. You often need this with aluminum. These torches found at Muggywell while supplies last. Never allow the aluminum to sit flush upon a metal table when torch brazing. The table will pull the heat away very quickly, causing undue frustration. Likewise, closing the jaws of a vise too close to the work area creates the same problem of heat dissipation. An easy solution is to lift the aluminum off the table with a steel wire. Another is using ceramic tiles or using fire bricks, etc. Thin aluminum cools faster than anything you will ever solder or braze. Make the process easier by not allowing the white metal from contacting heat sinks. The best way to apply the flux is to heat the rod for a second or two and dip the rod into the powdered flux. Repeat if the flux doesn't grab well. A common mistake is blocking the area with the rod before the aluminum has reached the working temperature. As a result, the rod inhibits heating the desired location you want the Super Alloy 5 to repair. Instead, broadly heat the area adjacent to the hole or crack. This technique prevents the surrounding aluminum from sucking the heat away. First, we preheat, apply the flux turns clear, flow the rod out flat with the torch. Because we're brazing on thin aluminum, we always keep our heat moving to prevent the metal from getting too hot and collapsing. Again, preheat the parent aluminum, paint the flux on with the torch, pull the rod back and continue heating until the powder flux turns clear. We turn the torch down a bit so the process would be easier to follow, and it will mimic some torches that do not have an adjustable flame. There were some contaminants around the holes, so we added a little more flux. Dabbed the rod to test the temperature and heated the rod slightly to soften it as we applied it to the aluminum. The next hole will close much faster as the aluminum is already warmed. Notice the flux is more active than before, cleaning the oil, dirt, and grease away while sealing the hole shut. Quickly pull the torch away once you see the rod flow out flat. When joining two pieces of aluminum together, a longer preheat is needed. Again, the flux will tell us when the metal is ready to accept the rod. We will heat the front, back, and side to side on both plates to bring the aluminum to the correct temperature. The plates pictured are only a couple inches in length and thin. If we were working on a larger project, we would preheat longer and possibly need a hotter torch setup like oxyacetylene. When working on thick to thin aluminum, add more heat to the heavier section, as it will take longer to reach the desired brazing temperature. We continue heating where the two plates meet, watching for the flux to turn from gray to clear. The more comfortable you get with handling the torch and what to look for, you will find yourself turning up the fuel on the flame. If we were to add the rod before the plate was ready, the rod would ball up. Discard the balled up material and continue heating the parent metal, watching the flux as the heat indicator. The flux appears to be fluid and active. Let's deposit the Super Alloy 5 while heating the rod and the two plates where they meet, front and back, side to side. This technique should achieve an even fillet on the front and back of the piece. Let the aluminum cool naturally and remove the flux residue with warm water and a wire brush. If the bottom plate had been sitting flush on the table, it would not have been easy to achieve the same result. We are demonstrating with the Bernzomatic 2-tank MAPP gas and oxygen torch. It could take a few times to set the flame as the tip of this torch is smaller than most. With a tip this small, you want to push as much oxygen as you can squeeze out of it. Again, preheat around the cut, heat the end of the rod, and dip the rod into the flux. Never press the rod down on the aluminum. It's not going to make the alloy flow better or faster. When the heat is correct, the rod will flow. Notice that we're heating the parent metal and the rod. Soldering is heating the parent metal to melt the solder. Brazing is heating the base metal and the brazing alloy after the metal is brought to temperature. Aluminum cools very quickly when the heat source is pulled away. Therefore, keep the flux container close to the workpiece to shorten the cooling time while refluxing. The angle aluminum pictured would be the maximum thickness for even the best propane torch. Always hold the propane torch perpendicular to the aluminum when soldering or brazing so the flame mushrooms out evenly. If the torch is held at an angle to the metal, the flame will bounce off at an angle. We use the sanding disc on the aluminum, and notice the color match. Time to close a hole in an aluminum John boat. Clean the hole of oxidation, crud, mud, etc. We have covered how aluminum cools quicker than other metals. In this situation, the white metal's rapid heat loss works in our favor when we attempt to bridge holes and gaps. First, the rod will solidify, bonding to the side of the hole. Then we practically paint the hole shut. So if you were brazing on a crack and accidentally blew a hole from keeping your torch in the same spot for too long, you see how easy it would be to fix your mistake. After we close a sizable leak, we add more flux to solidify all the deposits together. Remember, our flux is what allows us to have an airtight, watertight seal. After removing the flux with warm water and a wire brush, we sand it down and look forward to another day on the water. When using an oxyacetylene torch, a carburizing flame works better for aluminum. We are using the same process as earlier. Preheat the work area. Don't hold the torch in one spot for too long. Test the temperature with the flux and watch for the flux to turn clear. When the rod adheres to the seam, continue feeding and flowing the rod out. The bottom of these boats can take a beating, so adding a little more filler rod is a good idea. There is a learning curve to aluminum soldering and brazing. It may take running a rod or two before you get the hang of it. Same with electric welding on aluminum. Most welders would admit to having a longer learning curve when attempting TIG and MIG welding on aluminum. Just keep at it and make sure you have enough heat to do the job. Subscribe to our videos by clicking on the little welder guy. And to avoid contaminating the remaining rods in the PVC sleeve, use a moist paper towel to remove the flux residue. Thank you for watching our Super Alloy 5 tips and technique video, and don't forget to tell a friend to muggy weld it.